buy them, I'm going to be upset. I'm never going to stream again. So that's my call to action for you guys when it's time. If you want to see great content, like what's about to go down right now. I don't even really know what this website is. Hi, Clapper Sama. Welcome to my chat room. Yeah, we're gonna, good morning. Good morning. It's almost 9 o'clock. We're gonna play a little HackerRank. I've never played this before. I think I know what it is, but I didn't do my research because I'm a shit tier streamer. But all I'm saying is when I sell you guys t-shirts, if you guys don't even buy 36 t-shirts, that's it. I'm done streaming. I'm quitting the internet. I'm going to live in a monastery. That's the one where you make monks at Age of Empires, 100 gold, bro. 100 go. All right, let's go. Let's go. All right, what do we got to do? Oh, hint. Oh, I love when they give me hint. Oh, type return A plus B. Oh, boom. I'm a genius. Let's go. This is slow. No, it costs 100 gold to make a monk. Oh, wow, they're really... My student or professional? I don't know, man. I'm always a student. That's right. No, I'm a professional. How many years of experience do I have? God, I don't know. I think I have not many. That's right. All right. Continue practice. Oh, I can unlock a badge if I solve more problems. Okay. Oh my God, this looks hard. What do I have to do? Compare triplets. It created one problem for HackerRank. It triplets, blah, 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 blah. Oh. Wait, this is a joke. Really? So it's like this? Now which way was the less than? Alice receives a point if A is greater than 0. So if X greater than Y, ret sub 0 plus equals 1, L if X less than Y, ret sub, is that right? Go. Oh, I shouldn't have just submitted it. Oh, but I'm a genius. That's right. That's right. We got it on the first try. All right, next challenge. Let's go. Let's go. Let's go. Let's go. All right. How we doing, boys? How we doing? All right, we got to move the webcam. Is that what I'm hearing? We got to move it? All right. No. Don't move that. No, that's wrong. That's better. Boys, we just beasted some shit. All right. I must return a sum of all the elements. Wait, this is a joke. Bro, see, this is why we use Python. Because I can just do that and we don't have to deal with bullshit about like numbers being the wrong size and shit. Because we use Python. Let's go. Boom. Boom. That's right, first try. That's right, don't be a noob. All right, calculate the absolute difference between the sum of the diagonals. All right, we take the left to right diagonal, we subtract the left to right diagonal, and we have to ABS them. Oh, what is an array? Oh, it's like a... God, do I really have to write this? All right. All right, we'll just say like... D1 equals that. We'll say like D2 equals this. Oh yeah. Yeah, buddy. Yeah, if I did any thinking, this could probably be a lot faster. Is that right? I don't know, man. Probably. No! No, we messed up! We messed up! You guys gotta subscribe to my shit! If you don't subscribe to my shit, then you suck, and we're not going to stream anymore. Oh, I typoed. Oh, it's ARR. Oh, that was a dumb typo. I should have tested my code. Oh, that would have been so... Oh, no, we messed up. No, how are we messing up? Okay, what are we doing wrong? All right. I don't get it. That should be right. 2, 0, 0, 2. Sum across the primary diagonal, sum across the secondary diagonal. Take the absolute value and subtract them. Did I do something stupid? Oh, uh-oh. Uh-oh, 9/11 test cases failed. Uh-oh. Can I make the text a little bigger? Sure. For you, bro. Are you a subscriber? You gotta subscribe if you want big text. But I don't understand how this just work. What did I do? This is so stupid. The absolute difference between the sum of the two matrix diagonals. Okay, I sum the two matrix diagonals. 0, 2, 1, 1. What? Take the absolute value of the difference. Run code. Oh, they don't have to be 3 by 3. They can be biggie matrix. Oh, no. Do I have to write loopy? Oh, not loopy. Oh, that's so hard. Okay. For I in length. God, range, length. Hey, wow. We were so careless on this one, boys. We were careless. That's right. Don't be careless. Is that right? I think that's right. I don't know. We're just guessing. This is a guess. No! Oh no. Oh no, boys. We did it wrong. Oh, God. It's +1. Am I off by 1? I'm getting real sick of this. List index out of range. Okay. No, we gotta subtract 1 because 0 won't work. Yeah. Blah, 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 blah. You know what? It's early. It's early, boys. It's early. Right? All right. It's early. Yeah, no, I know. This stream sucks. I'm sorry. Oh, you're in the fucking star. Yeah, buddy. All right, let's go. Can I change my camera position to bottom right? You know what? Just for you, bro. Did you subscribe? This isn't the content you signed up for? What? You don't like my new programming? Come on, we're warming up. Now, the other thing we could maybe do today... Oh, this is so hard. You know what? No. All of you asked for this shit in the comments. All you asked for this shit in the comments. Thank you, NarcoRL, for subscribing. You know, I'm sick of all of you, you know? No, you know what? No more stream. No, there are too much haters in the comments. Too much haters. No, there's too much haters. No. Only because we have a lot of subscribers. But if I hear any more haters... you're all done. Right? Who's gonna kick the haters out? That's right. Ban the haters. That's right. No. Just can we ban the haters? No. Whoa. Who said I should develop a thick skin? You're a subscriber. You're allowed to say things like that. All right. What? No. Don't tell me I'm fucking tired. No. You know what? Watch this shit. Don't tell me I'm tired. You see? You tell me I'm tired? Time out. That's right. All right. Who else wants to be banned? All right. Who else wants to be banned? Yeah, thank you, ABK, for subscribing. Love when you subscribe. What's VLang.io? Oh, you want to be banned? Okay, Rither. All right, cool. Yeah, congratulations. Enjoy your fame. All right, you're banned. All right, cool. Get fucked. Who's next? Thank you, Fox Ubu. Thank you, Ivy Lions. Please subscribe. You don't want to be banned? Well, good. You're not banned. All right, let's go. Add a sublink in info. I don't know how to do that. I don't have Vim on this computer. You want to be modded? No. You want to talk shit? Yeah, you're a subscriber. Subscribers can talk some shit. Oh, yeah. All right, let's go. So you don't like Hacker News? No, everyone seems to like this. Look how many viewers we got. We got so much viewers. All right, let's go. Oh, shit. What is this? Plus, minus. A decimal representing the fraction of positive numbers in the array. Zeros. Okay. Is this gonna work? All right, now we're back on top. That's right. That's right. Now we're back on top. Who's talking about the Clintons? We have a rule in here. It's no politics. Get banned. All right. Who's sending me bits? Thank you for sending me bits. Congratulations. You solved your 5th code challenge. You know what? You know what? I'm in somebody's Skinner box. I'm in somebody's Skinner box. That's how I feel right now. All right. Is there more codes? Next challenge. Let's go. Consider a staircase. Do these get hard or are these all stupid? Write a program that prints a staircase of size n. Oh, I see. And I have to make it have spaces. Wait, this is a joke. You know what? I'm probably gonna do this wrong, so I shouldn't shit talk too much. For I in range, I think so 6 actually has 6. So we'll just say print, and that's actually 6. All right, let's go from 1 to n plus 1. Let's print space times I minus n plus star times I. Is that right? Did I do that right? Oh, you see, you can't use, you got to use hashtags, not stars. This is for the Twitter generation. What? But did I print one? No. What? It doesn't like my new line? Can I not put a new line at the end? Is that the problem? The last line must have 0 spaces in it. Well, it does. Okay. I don't know. So these things don't look like these things. This is stupid. I don't get it. Wrong answer, because I did that. Okay. Okay, guys, like, I don't know if I'm dumb, but they look the same to me. They look the same. Oh. Let's see my output. Well, I can't download my output. It's a formatting issue. This is just buggy crap. Ugh. I'm disgusted. No, it's not sysstandard out flush. It's not that. Did I just do it wrong? Space. Oh. That's wrong, but... All right, let's go. All right. Is anyone talking shit? Is anyone being a hater? Because we ban haters around here. We have a zero hater tolerance policy. If I had a plate, I'd break it to show how much we're gonna break the haters. That's right. Okay. What? Summing exactly the minimum and maximum value that can be summing each of the 4 elements. Oh, I have to beware of something. Let's read. Do I have to beware? Oh, beware of integer overflow. Oh, good point. All right. For I in range length ARR. Sum ARR minus ARR sub I equals AA equals that shit. Oh, you know what? Let's use a list comprehension. Yeah, we love list comprehensions. Oh, it's so comprehensible. All right, and now I have to return what? Print 2 space separated integers for the min and the max. All right, let's go. Let's go, boys. Let's go. Is that right? Yeah. No, we don't talk about openpilot in here. You get 1 warning. You get 1 warning. Let's go. First semester programming. All right. Oh, I'm in charge of the cake. No, okay. Who gave me this job? I'm not. Can I outsource this? All right. She blows out what? Return the number of candles. What? Is she like short or something? An array of integers representing candle heights. What? Your niece only blows out the tallest candles. She'll only be able to blow out the tallest ones. Oh. So basically you're telling me it's something like sum x equals max AR for x and AR. Is that right? Is that right? That's terrible code. Look at that. That's n squared. This is n squared. That's disgusting. It's disgusting that you can write n squared code. Okay, do these get hard ever? Or are these like for like, you know, the 90% of idiots that like couldn't pass like FizzBuzz? That's kind of how it feels. What? I did it wrong! What'd I do? Oh, is it too slow? Oh, do I have, wait. How big can these be? Oh, they didn't like my n squared shit. Oh, yeah. All right. Want to see how we're going to fix this? It's called mar. We're just going to say mar. Yeah. Wouldn't it be nice if like languages were smart and could kind of do that all for you? Oh, yeah. Didn't finish in time. Oh, yeah. Got to not write n squared shit. You see what I'm talking about? Oh, yeah. That's good. That's good. That's good. That's smart. All right. Cool. Well, is it people? No. All right. This is terrible. All right, time conversion. Okay, let's just say, you ready for some real hacks? H equals int s02. If s sub 2 equals pm h plus equals 12, return o2d s percent h. Is that right? Did I do it right? Yeah, that's good, right? Let's go. Yeah, let's go. Oh no, I did it bad. All right, what'd I do? Can it be like AM or PM? Huh? Oh, we got to deal with like midnight shit. Yeah. Is there a good way to deal with this? If this is not a MISRA-C compliant function, you know, because it has multiple exit points. Is there like a smart way to deal with that? Wow. I probably did it wrong. Compilation error. Oh, I forgot colons. Don't forget your colon. I think you need. Oh, what? Oh, this is stupid. Either that or that. If it's a PM, we do that. And then that. Oh. Oh, if I had 5 hackos, I could unlock the test case. Oh my God. All right, is the font big enough for you guys yet? Make a circular array. Why is this shit wrong? What'd I do? That's never 0. Oh, it's not. That's not right. This one is a generic case. Oh, there's subtlety. H plus equal 12. If H not equal to 12, right? Because 12 actually stays the same. And then what do we do if it's 0? Okay, so otherwise it's AM if H equals 12, H equals 0. And there we go. Oh, you're a big fan. Oh, thank you for mod 24. What do you mean by mod 24? Oh, I guess this could have been fixed by mod 24. And this is kind of just a bullshit rule. Yeah, I know. I could have just summed mod 24. I get it. Well, no, wait. No, I couldn't have. No, it's not mod 24. Because 12 p.m., if I add 24, I end up with 0. And that's not right. Whatever. All right, no, I have to like know which one's the. Oh, and I have to leave that alone. Oh, this is just painful. All right. A, B, C, D, E, F, G, H, I. Range from. Oh, no, but then, this is Python 3. Oh, guys, I'm kind of done. This is, can these be hard? Can we find hard problems that aren't like bullshit? Oh, okay. A, B, C, D, E, F, G, H, I, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. A equals that. All right, now we got to do K. So it's A sub K plus, I could do it without mod, guys. Watch how you do it without mod. Is that right? Raw. For C in S, if C in AA. Return join ret. If it's in the alphabet, what we want to do is say AA.index C raw sub AA index C ret dot append. Yeah, don't do plus equals in the strings. You know that's is that right? No. Okay. Well, it's wrong because else ret dot append C. Why did we get a Q instead of a? Oh, I got to deal with uppercase and lowercase. Oh man. C dot if C dot to lower is not equal to, no, but it's not even in AA at that point. Ugh. All right. Is Python case sensitive for variables? I legitimately do not know. I could have just done AA.to upper. Yeah, I know. You're probably over there in the comments right now talking about how I can do this much smarter. But, no, it's wrong. What'd I do? Or I can ask my friends for help on social media. What'd I do? Okay. Oh, look at that. Oh. All right. Who said I had to use mod? Yeah. That's right. It is basically CTF code. No, I love things like this because I wish they were a little bit harder and I had to think a little bit more, you know? And not just like, oh, I forgot the string. Oh, I got to do the string better. Oh, I got 2 stars. All right. Can I sell this account to somebody so they can like go interview somewhere? All right, let's go find hard problems. $99 points to next star. Let's try this. Oh, these look hard. 22 foolish primes. Okay. All right. This sounds hard. Hang on, I'll be back happy. Well, we're going to do some tea because it's tea o'clock. And then we're going to be some HackerRank. All right, let's go. Okay. Next Fallen Champ, thank you for subscribing to my channel. You guys should all follow his example and subscribe to my channel. Let me know that you appreciate content like this. Oh. Okay. Wow, I have to write my own reading code? No, I don't need to if name equals main. That's stupid. I can just say like... Is that right? I actually don't know. I don't usually read things from the EOF while reading line. Is it something like this? Sorry about the noob junk, guys. I'm a noob. Everyone knows I'm a noob. But if you all like noob, don't subscribe. But if... Wait, what? Oh, God. Gotta put parentheses in the right order. It's early. It's early. Why am I splitting based on that? Okay. Abstracting agent, thank you for subscribing. Let's see what we have to do. Okay, we got to stop talking stupid because those other challenges were pretty stupid. We got to start thinking slow. Okay, disks and set of disks numbered 1 through enter, place them on a random order. What is a partial derangement? Permutation event distinct when none of the items is in its original ordered position. Some, but not necessarily all. Okay, so if one thing is out of position, so exactly K. I'm not really understanding what natural positions are. Given the constraints, the answer can be represented as A divided by B, where A and B are co-prime positive integers, and B is not equal to 0, mod some... Wow, this is... Okay. Wow, this is actually hard. How do we think about this? Number of non-prime disks. And they want an exact number? Okay, well, so we're dealing with 10 million. So we can't use n squared stuff, but we could use n log n stuff. Well, I don't even, what is Q? Print the value of P times Q minus 1. But there's no other reference to Q. And is this the P they mean? This is insanely hard. All right, you all wanted, I know what the -1 means, but what's Q? Congrats, for claim your reward, Control W. You know what? Bad. I know, it's a medium, right? Am I just stupid? What are P and Q? Let's see the original problem. Maybe they give you more. Okay, well, that seems more reasonable. I know what... But what are P and Q? That's what I don't understand. Okay. Well, maybe we can figure that out. I'm looking at the example. So somehow 89 divided by 315 gets you this, which isn't clear to me. Like, I understand the probability. No, I don't think Q is some shit for math. I think, I don't know, like this problem just doesn't seem complete. Okay, so you're saying that A and B are P and Q, and this is like a typo, right? A HackerRank is kind of, this problem, I don't think it's like this is just wrong. Okay, so let's say they actually want A times B minus 1. Wow, I have to do a modular inverse for this stuff? I mean, and I have to like type it in this little box? I don't know. This is why I like Project Euler better. I get to use like Sage and Gimpy and stuff. I don't know if I can import Gimpy. Yeah, I don't. No, I get it. Wow, this stream changed fast into something that's hard. Okay. So, I mean, I don't even know. Is there something built into Python 3 to do modular inverse? Yeah, I know I can write the thing, but the modulus is prime. What? Oh, P minus 2, that makes sense because of Euler's the little theorem. Is that prime? Oh, it's prime. 9th smallest 10th digit prime. Okay. So yeah, we can just do that. Oh, that's a cool identity. You guys see the identity? Because, I mean, I believe if I say like B n minus 1 n, this should be 1. Right? Yeah, so that's 1. So if I subtract 2 here, oh wow, that's really cute identity. All right. See, oh, I love when I learn stuff. Okay. So now if we say, this should actually give me the right answer if we do A times T mod n. I don't know how that, all right, good. Okay, well, at least now we understand what P and Q are, and yes, there is a bug in the problem text. Now we just have to figure out how to get A and B. So that's the encode thing. I don't know. I mean, maybe the way the whole thing works, you actually have to do it. Ooh, dark mode. Ooh. No, I don't like. Okay. Exactly k prime number disks are found away from their natural position. I don't, why does it matter that they're prime? Let's read this. This is exactly 22 prime number disks. Oh, exactly k prime number disks. Okay, so we probably have to know how many primes there R. And then we want to work it out for exactly K. I don't know. Let's try that. Yeah, for some reason I don't think I can import SymPy. Am I a cheater? Okay, is it inclusive? 1 through n. So we want to say range. So we'll just say capital P equals map is prime range. All right, so we'll print what kind of is prime function is this? Never mind, never mind. I thought the internet would be useful for something. They weren't. Range, do square root of n. Math dot square root. If I mod n not equal to 1, false. What are you guys posting about stuff? You guys know things? Map object. Oh, Python 3. And that was wrong anyway. I'm going to do some. Float cannot be interpreted as integer. Thanks, broski. So you only have to check up to the square root of things to see if numbers are prime. Okay, I don't know why that returns 0. If I mod n, if n mod I, don't get it twisted. There's faster primality checks, isn't there? Primes is in P, guys. Oh no. Okay, well, so it's good. Okay, so there's 5 primes up to 10. So let's see, that's 2, 3, 5. 7 doesn't seem right. Oh, I guess it's counting 1 as a prime. If n less than 2, return false, because those numbers ain't prime. Yeah, that thing's definitely counting 1 as a prime. Okay, no, that's 4 primes. Sorry, that makes sense. Okay. X algorithm, thank you for subscribing. No, look, the answer's right because I hand-coded A and B, right? Like, we have to figure out what A and B are. So B is the denominator. What's the probability that we have a partial derangement? Okay, so that's, I think the partial derangement then is the denominator. Is a complete derangement also a... If some, but not necessarily all. That's just... Okay, well, so we have the numbers 1 through 10. How many ways could we possibly order them? That's 10 factorial? Is this, but... See, that even already might be a reduced fraction. And 10 factorial. I know it's 10 factorial, but okay. So then we do know that it's a partial derangement, which means not everyone is in the correct order. But there's only one solution where everyone's in the correct order. So it's n factorial minus 1, right? And then we want to know what's the probability that exactly k prime number disks are found away from their natural positions. Okay. So I don't think we have k and we have p. So we want p minus k to be in their correct positions. Okay, so p minus k disks total is n factorial minus 1. P minus k disks in correct positions, k disks in wrong positions. So now, I think we can just say that. Is there a Python factorial function, or do I have to write it? Def fact x equal return x times fact x minus 1. Oh, it has to terminate. Oh, you always have to write the termination condition. And 0 is a stupid thing. So we'll say b equals fact n minus 1. I think that's right. Even though b there changes, but that's because they just did the reduction. Okay, cool. Is that right? Good, my factorial function works. That's like a prime number, though. I don't know how. Is that prime? Well, yeah, but that's never going to be 315, so maybe I did something wrong, right? But that is, okay. It could be a partial derangement, does not include full derangement. If some, but not necessarily. See, this is what pisses me off about math. It's like, dude, can you give me a real definition of this thing? I don't know. Like, it's just people saying words, and the words, some of them mean things and some of them don't. It's cool, like there's really good thought in there, but like, I don't know. No, I mean, maybe this is just my complaint about their language. I've always found like mathematical language kind of hard to approach. Like, I don't know. But then again, it's not like, I guess for me to properly criticize mathematical language, I'd have to come up with a better way to talk about this stuff, and I'm not really sure I have one. Okay, what's the probability that we have a partial derangement such that exactly k prime number disks are found away from their natural positions? What if it doesn't want to be in that? What if it's a natural position? Well, that's a... Whoa. We don't do hacking on here, Alex says. I'm sorry. And we people who suggest hacking, no, we don't do that anymore. This is what you want to be seeing? Thank you. I would, actually. You know, no, Craig Hill, I really would. I'd much rather read a formal definition than to use the language. And maybe that is really the solution. Okay, any number of non-prime disks may also be found in or out of their natural positions. Wait a second, okay. What's the probability? Oh, okay, no. So this isn't minus 1. Okay, so the minus 1 is wrong. The total is just n factorial, right? Because the base rate's not that it's a partial derangement. The partial derangement is given. So, okay. This thing should have a factor of 315. It does, yes. Okay. So now at least we can say that A is supposed to be 89 times that, right? So real A is that. All right, cool. Boom. They don't follow that? 11 mod 3 is not equal to 1, so we conclude that 11 is not prime. Godel gang. Did I write a bug? Are you making fun of me because I wrote a bug? Did I write something stupid? Okay, so we have B, now we have to get N. Now we have to get A. So exactly K prime number disks are found away from their natural position. So that means, yeah, first off, so this is right. The only ones we care about are P minus K disks are in their correct positions. Also, this is just like this is just choose. This isn't that hard. If I remembered like 8th grade algebra, I'd know how to do this, but sad point is I don't. Okay, so these ones in correct positions, I think we can just ignore, and then N minus P disks in any position. All right, so yeah, take the coefficient of binomial distribution. It's some crap like that, right? Yeah, if I remembered exactly what that was. Oh, yeah, you're right. You're right, I told you I wrote some stupid bug. How is the answer still right? No, now it's 5. 5's not right. Wait. Equals 0. Oh my god, but we still get the right answer when we do all that stuff. Okay. Godel gang, thanks for finding the bug. Sorry, it's early. Okay. So we P minus K disks in correct positions. So these we only have one choice for. So let's place them first. Place them first, no choices. Now these ones have to be in wrong positions. So for each of those we get one less than, yeah, so it's like, all right, let's just write this stupidly, we'll think about it later. Okay, so let's just say Cn equals N minus P minus K. Cn minus equal 1. It's A times equals Cn minus 1. Not in correct position for I in range N minus P. A times equals Cn. Any remaining position. All right, so we're off by something. Let's print Cn and make sure that should be 0, right? So you have 1 out of n in correct order, then you select K disks, which you will derange. The formula for derangements is simply n over e. What's e? I'm sure there is a simple way to think about this if I really just thought about it, but let's first make sure I'm on the right track, and then we can go back and think about what it is. Natural log rounded to the closest integer. I never trust things like that. Okay, so you have them in the correct order, and then you will select ones which you will derange. No, but it's a little bit wrong because it's exactly right. But these must be in wrong positions. I think that's what I'm doing wrong here, like, That's what I'm doing wrong here. Like, this isn't correct. Don't forget those cadence to prime numbers. The prime number thing doesn't really matter. The only thing that the prime number thing tells you is what P is, I think. But this is wrong. Like, you can't just say not in correct position because, well, why can't you? The link to the problem, it's Project Euler 239, but made generic. Yeah. Imagination, you're a subscriber, so I'm trying to listen to you. But I don't know. See, I don't know. Like, it's hard for me to just trust that formula. God, wish I knew more combinatorics. Any remaining position. Okay, that's definitely right for these ones. No, but sort of not, because okay, let's just take a hypothetical case where n minus p is greater than k. If n minus p is greater than k, then we can plug up all the prime holes with those. Right? All right, let's look it up. Is this cheating? Leaves no element in its original place. Yeah, it's a bit... Okay. We have 1, 3, and 6. So... yeah, n sub p is greater than k, so I think the answer to this is actually just Cn factorial. That's not always the case. No, that's not right either. Okay, so p minus k. So k is 3. Tools permutations is fine, but that's never gonna, I mean, yeah, we could write that. I mean, maybe it's not the worst idea, but that's not gonna, I think these numbers have to be big, right? Yeah, iter tools permutations, n gets big. Okay, so if we have 3, and we know there's 4 prime numbers. That means 3 prime numbers have to be in the wrong place. That means 1 has to be in the right place. Oh, but okay. It can be any of the 1. Right? So actually, is the answer this times 4? No, that's not right either. Oh, combinatorics is hard. You see, okay, the mistake that I'm making here and why this is actually smaller than the answer is that in this one I've already chosen which prime has to be the frozen one, and it can actually be any of them. All right, who wants to write it with iter tools permutations? Let's just make sure we understand the problem right. Fine. Inner tools dot permutations range n. So that should make b equal to the same value, I believe. Yeah, that's right. Okay, now let's test to see if it's true. So we need p minus k disks in the right position, k disks in the wrong position. Okay, so we want to know the prime ones for, let's say, n, for I in p, if is prime I, this isn't exactly right. We want to say not just p, but we want to say enumerate p. C pos, W pos, if is prime I, so we only care about the primes if pos equals I, C pos plus equals 1, else W pos plus equals 1, if C pos equals P minus K, and W pos equals K, A plus equals 1. Is that right? If it wasn't on Windows, we could run this all locally. Oh. Well, that's too bad. Yeah, I know. The problem's not Python 3. No. Yeah, we memoized his prime, but he didn't fix it. No, I don't do it for fact as well because I don't use fact very much. It's just that this crap's really slow. Okay, we have to be slightly. Ugh. And this is fast enough, right? If we comment out this. That's fast. Okay. Let's just say list map is prime n. That's not really what I want. I really just want to go through the prime numbers, check them, but that still isn't that. They're hard, right? Like, I'm not just an idiot, right? Like, this isn't, like, obvious. I don't know. Sometimes I meet people who are just way better at math than me, and, like, it's like, oh, to them, oh, well, don't you just remember this identity? It's like Jensen's inequality, bro. I'm like, okay. I mean, I guess I wish I knew things like that. And then I question, like, is it just big built-up pattern matching, or is it, like, a real thing to know? Pause equals I. Okay, we don't really have to do this. We can say this map is prime n. Just enumerate map. Maybe filter lambda x. Actually, I can just say filter is prime range n, right? That'll just give me the numbers that are prime, and then I can try like for m in mm if p sub m is equals m c pos plus equals 1 else equals 1. Is that right? Stupid comprehension. Oh, okay, I think that's right. Yeah, okay, so that's the number I thought it was. So now we can actually plug these things into, should work fine, it's all mod. Yeah, okay, cool. Okay, so this implementation does work. It's just a little slow. P and Q are just A and B, it's a typo. Yeah, you're probably right about frameworks of thought. And then, like, you know, you think about when you learn frameworks of thought, and I guess it's at like a really young age, and then you realize that, like, the hacker skills are just a framework too, and you just see things other people don't. And I've met people who just see things with this stuff that I don't. I don't know. Like, I'm not sure how much you can learn this. But if you appreciate this stuff, please subscribe to me. I'm never above shilling. You should never be above shilling. Okay, well, this is combinatorics for idiots. But it is right. So now let's just figure out how to make this code fast. Now, this is the kind of thing where this is a correct implementation, and if the compiler were intelligent, it should be able to read this code and replace it with the closed form. But, as we know, intelligent compilers do not exist. All right. So let's think through what this is. I think it's okay. We have our three numbers here. Maybe the better way to think about this is to start with n factorial and just take out the ones that are incorrect. So we have in factorial. There's some, why are they wrong? Why does something not match? We need exactly a certain number of prime things to be in the correct place, and that's the reduced form. So it's like not a simple division. We need a certain amount of, maybe the way to think about this is to okay, they probably are data mining all the code. Probably the way to think about this is to say, what's the inverse of this? And then we can subtract it from all the possibilities, right? So what's the probability that we have a partial derangement such that exactly k prime number disks are found in their correct positions? If there are p primes less than n, then p minus k primes must remain in the same positions. Yeah. I have that. So let's see. Yeah, we need p minus k, and this is like a choose kind of thing, right? So it's p minus k. Out of p, we choose p minus k to be in the correct positions. Yeah. So this correct positions and wrong positions thing is maybe a wrong way of thinking about this. Maybe the right way of thinking about this is exactly a certain number must be in the right position. I mean, we can. Oh, yeah. I mean, this is. I didn't actually need to write that. I think I just need to write that. You can check if it's still correct. Yeah, it's still correct. Okay. So that's all we have to think about. We just have to think about exactly p minus k out of p things. No, I know. The whole prime thing is just a troll. So let's just give p minus k a new name. I don't know. P minus k disks in correct positions. So it's like p minus p choose p minus k or something. Yeah, there's p minus k fixed things, but we don't know, like you can choose which one out of those things you want to be fixed. No, but then the other ones are wrong, right? I like this. This is how I know how to do things. Okay, so let's just say C equals P minus K. Put that up there where we're computing these things. C pause, yeah. So, yes, C things are in the correct place, and we can choose out of P to pick those C things, but we have to pick exactly that many. I always just worry that it's like beyond what I can do, you know? I don't know. There may just like sometime when I'm thinking about this stuff, I think that like whatever combinatorics thing this is, it took some guy like 5 years to discover. And then how hopeless am I just trying to figure this out, right? Like how do I take this and turn it into a closed form? Okay, so we place, what's throwing me off is like we place exactly, we can pick C out of the K to place exactly in the right place, but then how do we know we're putting the other ones in the wrong place? I guess that doesn't matter, because you'll always have enough out of the other ones. Is that true? No. It has to be exactly. It has to be exactly that in the wrong place. Yeah, I remember one time I tried this like RSA thing for days and no luck. I posted it on my Facebook, and actually Sorek solved it, of iPhone jailbreak fame. I was very impressed. Okay. So n factorial are total. Let's just play around with this. So let's get the ones that are in the. How many ways are there to pick C from P? So that's like P choose C. Yeah, binomial coefficients. So we can say something like, let's print NCR PC, right? So that's the way to pick 4. And also it returned a stupid float. Ugh. Of course there's 4. I mean, I guess that's obvious, right? Because there's 4 primes and we're choosing 3. So you could just leave each one out, right? So this thing does divide 4. Just got to figure out how to get this number. So we also need now, okay, so once we've chosen the ones that we want to remain fixed, those ones are fixed. Now we're left with n minus c, of which k, yeah, so we have to deal with the fact that those ones have to be in the wrong place. So we have to exclude those which have is it k in the right place? Yeah, we have to exclude ones which have k in the right place. So how many of them are there? Well, of the remaining ones, please subscribe. Of the remaining ones, we have okay, I didn't have to do that. 3. That's not true in this case. Actually, in this case, 3 of the primes have to be in the wrong place. The 3 of the primes have to be in the correct place, so then only one of them is wrong. All right, so what if I just print NCR P choose C, so those are the ones I'm leaving in the correct place, times factorial of the remaining. So this is going to overestimate A. Factorial of the remaining is n minus C. So this number is going to be bigger than A. We have to exclude some. Yeah. Yeah, so then we have to exclude how many? This many. So maybe you can subtract to get that number. All right, so we want to know, out of these, how many have those ones, how many have the P, how many have the remaining in the correct place? I don't know what the hypermetric distribution is. Okay, so the problem with that is that's counting the ones that have things in the correct place, which we want to remove. Let's try that. No. I'm probably not going to get this by guessing. Probably shouldn't try guessing. Okay, guessing is a bad strategy. We have to try thinking. So choose the ones that we're putting in the correct place. Those are done. We don't even have to think about those anymore. We have n minus c left. C is p minus k. What is c in this case? C is 3. I'm getting confused. You know p is 4. C is 1. So we choose 1 prime to put, oh yeah, because 4 choose 1 is obviously 4. Okay. We choose 1 to keep in the correct place. Now, well, so there have to then be 3 that can't be in the correct place. Yeah. So it's not exactly fact nc minus 1. Say minus 3, and let's multiply this by 8 times 7 times 6. Is that the number? Yeah, it's the number we have to exclude, right? Oh, well, that's the number we have to exclude. Yeah, so you guys see where I got 8 times 7 times 6 from? Because there's one less possibility for each of those ones. Actually, maybe the whole answer. No, it's not right. Maybe the whole answer is just that. Right, because we're choosing the ones to stay fixed. Then of the remaining ones, we're getting, it's close. I don't know if that means anything, but okay. Let's go back to a simpler, so it's that thing I was trying before that kind of seems right. gives me that answer again. Okay, well, we know that's not right. Again, because I'm forgetting something. What am I forgetting? Well, so if those choose, okay, do we have to like place the other ones first? After we've chosen that, that's just done. Okay, there has to be, you know what, we could just look up a formula for partial derangement. Here we go. Here, examine the number RK where exactly K items are in their original ordered positions. But, I mean, yeah, that's effectively what I wrote. Why is this X? Oh, and the subfactorial. Okay, yeah, I mean, that's exactly what I wrote. This is exactly what I wrote here. And that would be the correct answer if we didn't have to exclude the ones where the other primes are in their correct position. So this is the formula for partial derangement. The problem is that we have some out of those. Yeah, we need to subtract values that contain primes. Well, the whole primes thing is just a scam. Where exactly K items are in their original ordered positions. Yeah, so that's right, but it doesn't say anything about the other ones. There is some clever way to subtract here. Exactly K items. So we can say that out of the other ones, maybe we can say up to. Yeah, I don't know what this is getting at. Good. At least I'm happy that we're on the right track. At least that kind of matched. Kind of matched what we had so far. But okay. The problem is that out of those 1.4 million, some of them have primes in the correct position. So there's three things in here. Three given things cannot be in a certain position. Okay. So any of three given things. Okay. So I guess I don't understand why I was wrong when I wrote -3 times 8 times 6, 7 times 6. Because that's not right. Like, you can see vaguely why it would seem to be right. How do I get 3? So 3 is just K, which is actually the number that I'm being passed in. So n minus K. Yeah. Well, first, let's confirm that these two things are the same. So I think it's this, if we want to say. You see, I was trying to subtract 1 from each of those numbers to exclude, like, the position. Yeah, okay, so that's the same. I'm not exactly sure why that's not right. Okay, so when you look at the first one, it's like The first one, there's one spot it can't be in. I don't understand why that's not right. I'm going to be an idiot and I'm just going to do it again and hope it's right this time. Yeah, we're going to do that. But it's still not right. It's close. Let's try to figure out what this is excluding that's actually okay. Oh. Any of three. No, they all can't. Every single one of them has a position that it can't be in. The problem is, if this one has already grabbed the bad position of one of these, yeah, see the problem? So if I place the first one, I have 8 possible choices. The problem is some of the 8 possible choices are these positions, and then that would actually give them all the possible positions. Do you see what I'm saying? Can I explain the problem? You gotta just rewatch the whole video. I don't know. Yeah, the problem is that once I've placed that, okay, I think we can actually write this. Let's just write it by hand, okay? So times 8. Problem is the next one's not times 7. It's not times 8 either. It's times 7 divided by 8. No. Yeah, but okay. So how often do I pick? There's probably an obvious mathematical construction for this. So it's 8 times 8, because there's 8 possible positions. If I put it in one of the positions, let's talk about the next one, right? So you can say it's times 7, but that's not really right, because 1/8 of the time, it's times 8. So we say A divided by 8 times 7 of the times it's that. Oh, maybe. That? That's right. Now we just got to do the last one. So the last one is well, okay. It's a happy hacker keyboard. Okay. Well, that solves it for that. And this explains why it's slightly under, because of these ones that we're excluding. Maybe we can try to figure out just how many we're excluding. Reverse engineer this by numbers. We should probably be using a smaller example. Well, that's like a nice sounding number. That's how many we've excluded, right? You know what? Let's just try to, let's do this, and then let's add back in the ones we've excluded, right? That's probably the easiest way to think about this. So let's say that. Now let's look at the ones where we placed the 8 in the 7 hole. So that actually means there's that 7 hole. 8 choices. For next, where we placed the 7 in the, wow, this is, six hole. This is going to collapse to something reasonable, hopefully. Is this how people do math? Okay, now we have to go back, place the 7 in the 6 hole. Okay, now we also have to ask the question about where we place the 8 in the 6 hole. So that's probably 7 times 7. Too big. Something like this is right, though. Well, actually, if something like this is right, we can make a statement. We can say that it would have to be some multiple of this, and let's see if it is. Wait, no, that's not. Didn't it print A? Yeah, this. So is it true that this is some multiple of this? And if so, what multiple? Is that right? Is that exact? Be exact. Oh, 356. Perfect. Okay. So we just need, if we just take this and we multiply it by 356, that's correct. Let's check. Okay, now we just have to figure out how to get 356. Yeah, cool, that's correct. Okay, how do we get 356? It's some crap like, yeah. Well, what's 8 times 7 times 6? We have to add 20 somehow. Oh, guys, I think we're getting close. In before I sit here for another hour. All right, we got to get 20. How do we get 20? So that's 336, is that right? 336, and then there's another 20. Somehow. And so those numbers are all way too big. What's 20? Plus 7 plus 6 minus 1. Plus 7 plus 6 minus 1. Seems right. We love guessing math. Who's smoking crack? Don't smoke crack, kids. Yeah, I don't know about the expert ones. Yeah, this is supposed to be medium. I don't know. All right, cool. All right, now instead of writing m in this stupid way, let's write it correctly. For let's say m equals 1 for I in range. So what number is this? How do I get to this 8? So it's n minus c minus 1 to n minus c minus k minus 1 minus 1. That's probably actually minus 2. That seems right. Okay. M times equals I. M plus equals I. M minus equals 1. Oh yeah, because it's fine because I have that -1 there. All right, perfect. Okay, so it's probably wrong, but we'll get to where it's wrong later. Don't need to print any of that. These things are just stupid, didn't mean anything. Definitely get rid of all this iter tools crap. That doesn't even do anything. That can be commented out. B is not defined. Ah, well, we just know that B equals factad. Did I write fact B? Well, that's dumb. I wrote factad. Basic programming. Cool. All right, who thinks it works? I don't. All right, it's all wrong. Okay, well, I didn't expect it to work. We'll see what we did in a minute. Wow, okay, well, that's great. They're all totally wrong. Okay. So that's like just library code. Above line, not wrong. I wash my hands. Is M still hard-coded? Where's M? No. Oh. Wait, what? Okay, well, I meant to delete that crap. Great job. You are good, bro. All right, well, that's maybe useful for something. That's definitely why it didn't work at all. I don't think CN is CN used anywhere. CN is only used in broken stuff. That's all broken. This stuff doesn't make any sense. Okay, well, we had an obvious bug. CN is not used. Number of disks in correct positions. Get rid of that. Total permutations. And I think this is all still wrong because this isn't fast enough, but okay, I mean, I don't exactly understand why this is true, but no, I guess it makes sense. Maybe. No, it's just justifying. Okay, let's try it again. We're going to get more right this time. All right, well, we got some right. Yes, this is basic programming, yes. N there is hard-coded, but that should be hard-coded. Wrong answer. Wrong answer. No, okay, it's still really wrong. I don't know. Okay, maybe that 20 just isn't correct. So correct times any placement be a little bit more careful about how we get M. And I think my M is the sketchiest part of this, the 356. Fact. N minus C, which we've already placed, minus 1 divided by fact, N minus C minus K minus 1. What? Okay. So we have to get another 20 from somewhere. The problem is that if we place the first one, if we place the first one, but you had 8 choices of placing. Oh, I love chewing ice, bros. It's a wonderful feeling. So we have like 9 possibilities, right? We have to think through what happens if we place. So there's one that we just can't place it in. And that's already covered. Basically, how many combinations? Okay, so this is all the combinations where none of the primes are... The thing is, the primes can be placed incorrect. The primes themselves, what this is excluding, okay, so we have 3 primes. What this is excluding is when the primes are, basically they're all outside the set now. We're saying that, like, we couldn't have placed, no, it's not right. Yeah, I'm sure there's a more elegant way of doing this too. You know what? I know an elegant way. Let's just see how many of these are correct. This should be completely correct, except for the fact that it's going to time. Oh, okay. If this is getting stuff wrong, then the stuff we don't understand about the problem. It isn't like some stupid thing like that, right? Now, yeah, how is this getting, okay, if this is getting the wrong answer, then the stuff we just don't understand. Right? Or like, my is prime is wrong or something. NCR doesn't matter if it's wrong. I really doubt my factorial's wrong. Wait, what? Test case 0 worked before, didn't it? Is my is prime wrong? I know I wrote above line not wrong, but like that really shouldn't break anything, right? I should actually be able to test all the way up till n. Is this wrong? Well, first off, I don't think the memoization really helps. Let's move MM up to here. And then P is just length MM, print MM. Three, 5, 7. That's just not right. How did that break? All right. That is a clever optimization. Stop being clever. Well, that's definitely correct. Oh no. Let's just try. Is prime code wrong? I'm using the formula. There's 25. Okay, no, that's not wrong. Yeah, like if this is getting answers wrong, then there's just something I don't understand. Because this is just doing, like, how many of them timed out? They should never return wrong answers. Yeah, it's giving me wrong answers. It's timing out on a lot, but it's also giving me wrong answers. So we have a definition problem. This is checking how many primes are in the correct position. It's checking that it's exactly that. And B, okay, I mean, is this P and Q stuff? Exactly K prime number disks are found away from their natural positions. Disks numbered 1 through n. Oh. That could be what's wrong. The disks are numbered 1 through n, not 0. Yeah. I'll do that too. Because, yeah, n is the prime. Stupid math people with their off by ones. You can figure out what that is later, but let's see. No, still wrong. There are n total permutations. That's still correct. 0 is never prime, so that's not even a question there. That would change the length slightly. No, but there's a ton that are actually wrong. Oh, runtime error? Well, that's a different, okay. Is there still some off by 1 crap? Oh, okay. Math people. That. We have to check the index of the array, right? It's amazing that it was right at all the first time. Let's see, is this right now? Ah, okay. We're still getting some wrong ones up there, but this is definitely maybe less wrong. Okay. So I don't know. I mean, the other ones could all be timeouts. At least we're getting the simple test cases correct now. Now let's go back to our, see, it's always important to get the not execute within the, okay, these ones, okay, we're still getting runtime errors. That's weird. I wish it could, you know, tell me what the runtime error was, but I guess if it told me that, it'd be cheating. When could there possibly be runtime errors? Can these like be negative or some crap? Or you know what? This. No, that should be efficient. Modular power should be efficient. This should be efficient. I mean, I don't know. Runtime error can mean a lot of things. Okay, let's see if we're getting. So we're getting test cases 0 through 5 correct. So now let's see if we get it correct with the close form. By the way, this here is the derangement formula. Like, don't think I'm not using the formula. I derived it. It was simple. Okay, wrong. Only because I'm printing M. Don't print M. So P might have been wrong in those cases. So that was actually something the off by 1 error caused. Okay, so a ton of these are wrong. The closed form does not match the other form. Would the off by 1 errors cause this? No, they wouldn't. They could have caused P to be wrong, but that's probably not the issue. Oh, look, we're getting test case at 8 correct. Well, at least we're not timing out. Are those runtime errors? Oh no, we're timing out. Okay, some of them time out. Problem for later. Okay. 356. Well, that's correct. So that's 336. We're back to asking the questions about whether I got 20 from a really sketchy place. Well, so what if we instead start out with just the formula, and we want to figure out how to subtract the bad ones. The bad ones have any set of 3 primes in their, any set of 3 things in their correct place. So there's 3, it could be 1, 2, or 3 that are in, well, it's K. Out of those n minus C, there can be K things that are in the correct place that we don't want them to be. So why don't you Google? Where did I get the derangement formula? It's right here. That is exactly what I wrote. Read input from standard in, print input to standard out. Very good, we're doing that. Oh, you found my error? The n is different from, subfactorial. Oh, maybe you're right. What's a subfactorial? Wow, that's a scam. All right, we were wrong. Subfactorial. No object appears in its natural place. Yeah, I guess I should have paid more attention when they put the exclamation point on the wrong side. All right. Well, thank you. Please subscribe, even though I don't know what a subfactorial is. All right, you were right about the E shit, too. Yup. The hands are washed. You know what? They're going to come back dripping. All right. Yeah, I mean, this here is like what I'm deriving, I think, the subfactorial shit, right? Because it's not... Subfactorials seem to be a question of... Exactly K items are in their original ordered positions, right? So this isn't... To be fair, what happened is I misunderstood the partial derangement. So it still isn't exactly this, right? In which exactly K items are in their original ordered positions. I think what I'm trying to compute here with M is a subfactorial. All right, so maybe we can just take the equation here and figure it out. Satisfies the, yeah, and I think this is right. Here, satisfies the recurrence relation. N times the subfactorial of, do you want to just copy that formula? M is a subfactorial. See, I derived it. All right, all right, all right. Imagination, you're right. It's still not the right answer, though. I just want to make that clear. If n equals 1, return 1, return n times. Should we try to like learn instead of just copying? Let's try to learn. Yeah, that's why that like stupid -1 got in there, but this is the right thing. Subfact n minus 1 plus -1 times n. Why is that bigger? Definitely shouldn't be bigger. How are subfactorials bigger than factorials? Put it up there by fact. It's minus, isn't it? Plus -1 to the n. N times the subfactorial Are subfactorials bigger than factorials? Does that make sense? Well, maybe. Formulas n for n equals, oh, it's 0. Wait, no, that can't be right though. That's probably right. Is it smaller? Be smaller. Oh, good, it's smaller now. Okay, so now we want to say something like fact. Well, we know what m has to be, so let's just say m equals subfact. Maybe if I just replace these facts with subfacts, it'll work. Do you love how I do math, guys? Come on, 356. 337? Maybe it just assumes a fact? $123. No good, no good. 337 was pretty close though. Maybe this one's a fact? all right, I'll stop being stupid. No, okay. In reality, we want to like just stop subfact early. So it's this. So we're going to say m times equals I. Not right. Okay. I don't know who Khabib and Portier are. Let's think for a little bit. So we need. Let's test our subfactorial function. $44. Huh, that looks good. Okay, wait. So we put in 5 and 6, and we got 44 and 265. So that's 1, 2, 3, 4, 5. Okay, that's right. Well, those can be placed anywhere, those last ones. But out of those three, they can't be placed anywhere. Oh, it's just that. The problem is I had that janky -1 in there, where maybe I didn't need that. I don't know if subfacts work like factorials like that. No, they don't seem to. But you see the problem, right? Okay, so now maybe we can re-add the ones in where it doesn't matter how they're placed. The problem is there's how many that we don't care where they're placed? N minus P that we just don't care where they're placed. The problem is this is excluding all the ones where those are placed correctly. So if there's N minus P that we just don't care where they're placed, then, yeah, this is excluding all the ones where any of those are placed correctly. Oh, this is getting hard. Where any of those are placed in their correct place. No, we're better off going with what we had before. We want it to like not become subfact at a point. So maybe we should just write a custom. Call it lame fact. If n greater than k, is that right? No, not right. I think what we actually want to see is that. Oh, let's see, K. Okay, so for 9, 8, close. See what I'm saying though? Is this going to require us to understand what these things are? That would suck. I hate when you have to understand and you can't just brute force. Brute force is great. Brute force is a solution to all problems. It's too big. Too big of a number. Okay, lame fact didn't work. So those are okay with it being placed anywhere. This is going to be smaller, because those are just the derangements. All right, we can go back to trying to add them back in. P and Q are just A and B. We can go back to trying to add them back in. So this is wrongfully excluding anything where M should be 356. So we have to figure out how to get 356 out of this. Let's just look at the definition. All right, let's go back to where we were. You threw me off with all this. We were close before. We really were. This is subfact 9. That. So that's the All right, it's a common combinatorics trick to like double count some and then subtract those out. So, okay. All comb even bad. JT. Nine. $356. These divide nicely. I don't think these ones do. Yeah, subfactorials just don't divide nicely. I have to do some other subtraction stuff, right? Okay. None of them place correctly. Any shot it's that? It's not that. Okay, so that's any possible placement of those. It's like the problem is in this 876 thing. If we understand why we had to subtract 1, maybe then we'd understand why are the subfactorials this? Number of permutations of n objects where no object appears in its natural place. For those ones after that, we don't care. Could it be this? Okay, like, so this is undercounting. I got rid of what the right number is supposed to be. Why is this true? It's not obvious. N minus 1. Eight generating functions. So 356. start here, this undercounts. Because there's n minus c minus k that can actually be placed anywhere that here are not being allowed to be placed anywhere. So if we add back in all of those possibilities, right, that's not easy though. What? I'm not reading your paste bin, guys. We're gonna solve this. I'm okay if it teaches things. Like, we're so close. Okay. I mean, I guess, like, m should be something that we can calculate. The problem is we're just excluding some of the possibilities. In m. I had this worked out before. Okay. We were excluding the possibilities. There's really yeah, that's right. I don't know why that -1 is there. That's the thing that's throwing me off. Which makes you think that this just might not be right at all. Subfact NC. But it excludes all the possibilities where I don't, like, for me to understand this, I'd have to understand how subfactorials work, and I don't yet. There's this other relation for them that maybe is just more correct, right? So if we want to figure out the subfactorial of n, we can just say, and like we can even probably get rid of that because that's probably just going to fall out. Let's just write it. Let's just write the whole thing out. All right. So it's 9 minus 1. Stupid. We can't get, I mean, that's not obvious how to get that. Like, the only real way to get that is with recursion. Stupid plus, like, it factorizes, right? Spanler, thank you for subscribing. Yeah, I went to the bar in New York. It's that hotel Tesla died at is now a bar. It's pretty nice. Let's see. Okay. What if we start with that? Then we want to figure out how to add to that, right? So let's just say mm sub 0 equals fact n sub k. So what if we say that that's the previous subfactorial, right? Now we say sub 1. Actually, that one we can just do. mm equals 7 times mm. I think we can just make this m. Just pretend that's that. Plus 1. Eight times m minus 1. 9 times m plus 1. Or, well, let's say 7, so 1 minus 1, so it'd actually be the other way around. Does that give the right m? $440. No, that's not right. $287. That's not right. $385. That's not right. This is the definition of subfactorial, right? I have the exact formula for subfactorial of 0 gives 1. Yeah. But I don't care about the E crap, right? Like, we're trying to get an exact answer here. Trying to get the number 356. So we can say, okay, m times equals 7, m times equals 8, m plus equals 6, m plus equals 7, m plus equals 8, m minus equals 1. Okay, it's stupid, but it does give the right answer. $356. Okay. 6 plus 1, 7. No, but this isn't really what I want. So this can be 6 times m. I mean, I want to like shoehorn the subfactorial formula into this. I mean, maybe there really isn't a way. Let's see. Yeah, I mean, with the minus ones, there just may not be a way. I was trying to do this with lame fact, but that would be if we continued the subfactorial formula. So this is 6, right? Yeah. So that would be like if we see, I want to combine basically a factorial and a subfactorial. Don't talk about comma here. If I hear any talk about comma, ban. Oh, just how do I get 356 in a repeatable and reliable way? You don't need the E shit. The E shit's useless. If you figure out how to use the E shit, then you know what? You go solve the problem. Because I don't think we need the E shit. Okay. We got to just use counting arguments, like proper counting arguments. Even bad. Because the okay. Exact partial derangement formula. The number of derangements is just the subfactorial. Yeah. Inclusion-exclusion principle. This is what it is. Oh, I remember this. I remember this. Okay. Yeah. So it's the inclusion-exclusion principle. If we're trying to get A union B, yeah, inclusion, exclusion. It's this. Satisfies the recurrence relations. See, how long did it take Bernoulli to solve this? That's the real question. So 356 is some form of inclusion-exclusion. Okay, so let's say we start out with 9 times 8 times 7, which is the remaining. But then we have to exclude the ones where here. Start out with all of those, but then we have to include the ones where the first one was placed in one of the other two holes. No. I don't know. Can we start with any of them? But then we have to exclude the ones where the first one was placed wrongly. So that's just 8 times 8 times 7, which is not right either. It's like something like that, though, I think. No, it's not that. Okay, let's really just try to think this through at the beginning. The problem there is just we aren't counting ones where this one Oh, is that right? Yeah, it's 356. Okay. No, well, it makes sense to add 6, right? Imagination, I appreciate you with the subfactorial stuff before, but you're on thin ice. You're on thin ice. Let's just say you're on thin ice. It's like inclusion exclusion, right? Like we're getting somewhere with this shit. And parentheses. Where it's not a parentheses problem. It is something like this that gives that thing, though. Times 1. I mean, It doesn't, yeah, okay, it is obviously that, right? Like we don't need to actually add those parentheses. Okay, so what is this generically? We want to do 9 to 7, but without. So what if this number were longer, right? Like let's see if we can figure out the generic pattern, right? So let's say it's 9 times 8 times 7 times 7, right? Then to follow the pattern would be, okay, this isn't obvious at all. Never mind. Never mind, this is stupid. We have to truly understand how subfactorials work. Until we do, we'll never solve this problem. Okay, let's think it through in a small case. Let's think it through small case time. Small case. You're getting imagination, you're up thin ice. Drinking tea and peeing is the absolute joys of a Saturday morning, which is now becoming a Saturday afternoon. Drink some more tea. I'm gonna calm down. I'm gonna solve this problem. Yeah, you like my futuristic furniture, bro? Okay. You know what? I really don't like how big this text is. I can't see my code. Let's start with that. I'm just stupidly trying numbers. Let's not stupidly try numbers. Let's be intelligent. I really just want to compute m. Because there is an m. There has to be. Well, maybe there's not an m. Maybe just the fact that this works is just a scam. We've already placed those. We're left with a question of NCK placed anywhere n minus c total. K not placed in a certain spot. N minus c total. What if I just say n minus equals c? So that's already taken care of. I just need to multiply by a. Subfact n would be all n not placed in a certain spot. Fact n would be with them placed anywhere. So if we say A times equals fact n minus k times the magical 356, we get the right answer. Now what we should do is we should use machine learning to take in, there's some function of n and k which outputs 356. Right? We really boil this problem down now. Look, we're trying to be constructive. Okay. We don't know that that even always divides, so this might not even be true. Not placed in a certain spot. All right, so if we have fact n, we want to, let's look at the inclusion-exclusion principle. Trying to get the union, so that's not right because fact n's already overcounted them. See, the thing is, there's great ways to get at this with factorials, and it's like this. Like, you almost feel like you want the answer to be this. You think that should be 356, right? Like, that's what you think the answer should be, but it isn't that. Okay, subfact n undercounts because there's k that can be placed anywhere. So deliberately excluding ones with k's placed in certain spots. Okay. So let's go through, let's go through. Subfact n excludes, let's say for one of the k's, how many spots could have it been placed in? Only one, right? And then out of the rest of them, how many of them could have been placed? So let's place that specifically. And then say of all the other ones, after we've placed that one specifically in its one spot which was excluded, this is close. Not close. Okay. The problem, okay, what this is missing is that see if that's like a multiple. It's not. So we're going to have to add. Is that right? It might be that. No, it can't be that, because I added all the subfacts. No, it's not even enough if you add them. But that does seem like that's on the right track. That's still too small. That's all the derangements of all the other ones, given that the first one was placed in the one spot it's not allowed to be placed in. Yeah, we're way past any of the prime shit. We're just saying we have k that are not placed in a certain spot, and all the other ones we don't care about, right? Oh, it's actually all the other ones we don't care about, so it's n minus k. The way to solve the problem is go backwards. Well, thanks, bro. Now, this isn't going to work out to what we want, but it's close to this. Okay, we have to add back in. Let's pick one of them. Let's pick one of the k and place it in its disallowed spot. Right? Then of all the others, we have subfact n minus 1. But that could actually be true for any of the k. Okay. So we're going to say this could actually be true for any of the n minus k. Something like, we're getting closer, we're getting closer. All right. There's more. Because there could be two of them placed, right? So too much. Of the 2 is already included in the above. Okay, 9-3. Subfact. Dirkmo, is that actually right? No, see, okay. No, we're close with this stuff, right? So any of the n minus k, any of the 6, can be placed in their correct spot. And then all other derangements are allowed. But the fact that their derangement promises you that none of the others are placed. So let's see, how many possibilities are there that 2 are placed in the correct spot? Right? It's not actually, it might. So that 2, how many? This seems intuitive, but it's not this. That number's huge. Definitely not that. Ah, well. Choose 2. So this shouldn't actually be, this should be a choose. n minus k, choose 1. N minus k, choose 2. Minus k, choose 3. Subfactor minus 3. I think this sequence might converge to the right thing. And then like 6 choose 6 just has one possibility. Is this right? Sweet. Okay. It's this. I don't know if there's a way to collapse that down, but okay, does everybody understand why it's this? I think for completeness, we can even write choose 0 here. Choose 0 is always 1, assuming my NCR function is correct. Yeah. All right. It's not brute force. I mean, let's just write this as for I in range 0 to n minus k plus equals minus I. Pretty sure this is right. Yeah. What? Huh? Didn't we just have it right? Is that not the right number? It's off by 4? What? Oh. Did we not have it right before? What changed? What broke it? That's right. What did I do? For A in range. Oh, I guess I didn't include the last one. Because first off, AA equals 0. This is a sum. Plus that minus I. This isn't brute force, guys. It's like very reasoned why. Minus k plus 1. So minus k plus 1 will go to 6. Okay, now we have the right answer. Now we can comment this out. This may be too slow. We may have to figure out an even more closed form. Okay. I don't know why we're getting 1 and 2 wrong and getting all these other ones correct. Probably some bug or typo or something. All right, we're getting close. We're getting close. What do I think of the colon? It's okay. We're getting close. We got most of them correct. We have runtime errors. How do we have a runtime error? So we can also make this, I don't know if any of these are timing out. Some of them are. We can make this a ton faster. I don't know how fast my NCR is. But okay. So most of our remaining bugs are some runtime error. We had that with the itertools one too. Let's make sure all that's commented out. Yeah. Where could there even be a runtime error? No reason to memoize that. We memoize as prime. The denominator be 0 here. Yeah, that's probably what it is. Probably have to deal with the degenerate cases of NCR. So I don't know what the degenerate case solutions are here, but like, yeah, that's going to end up being a divided by 0. It's going to end up being a divided by 0 if, well, I guess if R equals 0. Can R equal 0 in any of our things? If R taking, I guess this is one way to choose 0, is that right? I can fix the runtime error? I fixed some of them. Where else do we do division? I mean, that's the only runtime error I can think exists. By the way, there are really cool ways to leak information out of these problems using that, right? Like if it tells you there's a runtime error, you can like leak a bit, right? Halt versus runtime error. Thanks for the bit leak, bro. Okay, wrong answer. Well, that's a different problem. So maybe the answer here is actually 0? Maybe there's 0 ways? 0 ways to choose 0? There's not 0 ways to choose 0. And it's offended for me even suggesting that. Oh, I guess, no, that's not even a problem because it's not going to reduce to, it's not even being divided by, that's just wrong. Okay. Runtime errors are still happening. The runtime error is probably happening somewhere else. Automod, my favorite IG thought. Yeah, I'll allow that, of course. Thoughts allowed. Asking me questions about my personal life or comma.ai is not. No, we're getting close. Look at all that. Look at all them check marks. You know, I wish I had a check mark on my Instagram. Okay, where could there be bugs? Where could there be runtime errors? Let's just see if it makes it to here. Or maybe we can test it on a few examples. Test against custom input. I don't know. Here we go. Oh, maximum recursion depth. Oh, that's a good point. My subfact function is shit. If n equals 1, return 0. That was in the definition. Still wrong. Well, maybe actually we try. All right, we got some number out now. It's not test against custom input. Let's submit it. Those ones are wrong, but I don't know about those. Those ones might be out of time or something. Come on, 1 and 2. Oh, we got 1. Okay, good. Now all these ones are finishing, and I hope those are all timeouts. In which case, runtime error. Some of them are timeouts, but this is a more clever runtime error, I think. Maybe it's overflowing some shit? I don't know. Let's try big numbers. $10 million and 1,000. Let's try. You know it's overflowing, just mod every number. Runtime error. I don't know why that's called runtime error. Could it just be is prime? Oh yeah, we can add my speed hack back to is prime. Because otherwise that's n squared. Yeah. My is prime function right now is n squared. So let's just say int square root n plus 1. Math.square root. We also don't actually have to build the list here. We can just say p equals sum map is prime range n plus 1. Is this more than failing? It's possible also this runtime error is on the output, like those POWs are overflowing. Yeah, I mean, I guess the factorial can get really large, right? We're doing n factorial, which this factorial is a huge number. Yeah, that's a lot of digits. Okay, well, that's why it doesn't work. Oh, okay. Well, good news is all of this stuff is junk. And any shared we could do the no, but it's not actually, it's not the primality that's causing the problem. My primality is now n square root n, which is fine. It's this. Well, okay, so we know P is about ln of n. I don't know, I'm pretty happy. I think we solved the problem. I think we just wait for computers to get faster and then we can solve the other ones. No, you know what that actually is? The runtime error is recursion depth being exceeded in the factorial function. I mean, we can fix this. Ret equals 1 for I in range x. Ret times equals I. There's no reason this has to be implemented. Now we're going to get timeouts, hopefully, instead. we're still getting runtime errors. I don't know. But we can check if that's actually already happening by here. See if those are runtime errors. In which case, we're going to have to really think about what this is and where these things are big. Nah, just wrong answer. Okay, well, it's not there. Let's see if we're getting a runtime error by here. All right, this is kind of cheating. Oh, subfact could have too much recursion. Yeah, okay, we'll write that non-recursive too. All right, who wants to do E shit? Is it just E? E is the usual. Runtime error. Okay. So it is caused by recursion in the subfact function. I don't know. How much subfacts do we need? Can I just pre-compute all the subfacts? Because there won't be recursion if I pre-compute them all. Oh yeah. Yeah, this is actually a stupid way to do this. For j in range, we need them all the way up to n. Subfact n. Pre-cache. That won't have recursion limits, right? Or I don't know, might. I shouldn't though, because I'm pre-caching them all. All right, who sees what I did? Who sees what I did? Okay. Woo, woo, we got a green check over there. Love my green check marks. They're not blue check marks, but they are green. Okay. These are probably all timing out. I think they just need to buy a faster computer. That's my thoughts on that. No, guys. No. We can't do that. We have to win. We have to win, but we're making so much progress. We're getting almost all of them right. You know, someday I dream that the computer can just deal with this shit for me. Okay. Problem is that the factorial of 10 million is just too large of a number. The problem isn't even the for loop. I mean, how can I optimize the for loop? We can talk about that. But I think we're actually just dying here, right? There's no way we're getting the factorial of... I mean, maybe. It's like a 5 megabyte number. That might be okay. I don't know. Well, so here's an interesting realization. I believe that we don't ever actually have to compute that. I think we can do it inside of here. Say just t equals 1. Right, it's a ring, right? So for I in range n, 1 comma n, t times equals. Should be the same, right? Nope. Not the same. Why not? Oh, because it's inverse. That still should be the same, right? Wrong answer. Oh, because I changed n. Oops. This is why you should stick to the single static assignment forms when you are writing a program, because the single static assignment form doesn't do this. Wrong. That's the same wrong answer I had before. Maybe 1's not the right number to start with. My point is, okay, you know what? No, I think the factorial can be done in the modulus. Yeah, that should be okay. If I do the factorial mod n, right? So we'll say like b equals 1 for I in range n, b times equals I. Sorry, old n. And then if we put b there, this is okay? Not okay. Why not? If I make this fact old, then it's okay, right? Yeah, huh. Why is that? Is that not the factorial function? Oh, alt n plus 1. Did I just forget a plus 1 in the other one too? Well, either way, it doesn't matter. Okay. This should be fast, relatively, right? I mean, yeah, that's over. Now we have to figure out how to make the other thing fast. The subfacts, I guess we're doing it all in the ring, so it's fine. We just need to pre-cache the subfact. Yeah. Yeah. You guys see what we do, right? BTM Ole, thank you for subscribing. Thank you for subscribing. You're a bro. Yeah, we just do. Does it terminate your timeout if I get rid of that? Probably still does. What if I just take this n? Yeah. Everything's just mod n, right? So... That's right, isn't it? I don't know about pluses. Pluses might break mods. That's a later problem, though. Pluses don't break mods. I don't know what the time limits are. Is it possible now that I'm just not well? So this n minus k plus 1. Now, k should be relatively small. This should be n log n. Well, that's not really fair now, is it? I mean, k should be small. Has to be. The largest possible value of k is yeah. It's kind of big. Copy and paste this and put it somewhere safe. Monica subscribe. Thank you for subscribing. I appreciate you. Sam, the program. What is this you guys are talking about? I don't know. I mean, the NCR thing, I guess, also can be Let's first just make sure we didn't make any mistakes. God. Oops. Because I didn't define it until there. How did any of them run? Maybe this isn't right. Okay, so let's look at the chooses and see if they're going to be big. P choose C, that's probably pretty large. Yeah. I mean, we might have to just rethink how we're doing this core thing. That just might be too slow. Let's think about it. We've narrowed it down to the sub-problem. Oh, I did triple bite. I scored in the top 2%, and now they keep hitting me up for interviews. You can work at great companies like Cruise Automation. Oh, wow, the Cruise Automation, wow. What is this? This should be okay, actually. If it gets to here within the time limits, we can fix it. Because this here is actually yeah, we can figure out how to more quickly do all the NCRs because they're all in order. This should be like Oven, right? No, these ones are still timing out. But less of them are timing. No, it might be the same ones. Starting with 26 is timing out. Is that the same ones that time out if I submit it? No, there's more timing out. Okay. So it is just this being slow. That stuff's definitely not slow. This here, yeah, it's only because it's doing that reduce. So what is the formula for NCR? It's this. You know what? We're just going to replace factorial with a and this should scale, right? It's only going up to 10 million. Unless they have some small stuff, we should be okay. H2 to N. Well, this is just slow by design. This is after we've read N, right? That's before we've read N. That should be real fast, right? One more. Okay. So now we can leave that NCR, but this NCR we have to make fast. Fact n minus k divided by NCR. Yeah, okay. Fact I times fact n minus k minus I. There's a lot of ways we can make that even faster, I'm aware. We'll get to that in a minute. Okay, well, it's because I didn't use that kind of division. Let's see if this is more correct. It was finished fast. Are they wrong? You might have missed the same exact ones. Oh no, we got, okay, good. Yeah, okay, it's all just time limits still. Oh. Mod N. It's not right. Oh, it's not right. Why is it not right? Because that divided by is not a divided by anymore then. Ugh. It's not that the factorials are wrong, it's that we can't divide like that. Is there another NCR formula that doesn't divide? Dividing is really just a way of subtracting. Oh, you got 4 test cases right. Nice job. You're getting there. One day you'll be a lead hacker. Use my same trick for inverting, I think. I don't know if this keeps any of the performance guarantees, but might be able to cache those in linear time. That's a lot of correct looking ones. All right, good. We're getting less wrong now. Now we're getting only the ones wrong that were wrong before. Now we're getting only the ones wrong that that exited early. Oh man, this is a lovely Saturday morning, guys. I'm happy to have all of you here with me, and we're going to solve this problem because we believe in ourselves. You know, I don't know, man. All the millennials who were raised on that kind of we believe in ourselves shit. Code did not execute in the time limits. I know, we're working on it. So I think it's just is pre-caching all the factorials too slow? Let's see if that doesn't execute in the time limits. I don't know what their time limits are. This I feel is a fair test because this thing would probably run on my computer okay. It is now OVN. It might be my subfact precacher that's too slow for some reason. It shouldn't be though. Yeah, these are not executing within the time limits. Oh, is it actually happening before that? Maybe. Is my prime thingy too slow? Oh, that would be great if that were the case. That would make fast, I think. Yeah, so that's n square root of n. That's not fast enough. Yeah, that's the problem. It's requiring 10 billion ops. Water. We're switching off tea. We've been too hyped on the tea, bro. Got a latte this morning too, you know? Yeah. The prime shit's just too low. Okay. Too slow. Fast way to count primes below n. Wow. Wow, these look complicated. The sieve of Arachnes is... Okay, we'll do the sieve of Arachnes. That's not... It's still not n. Maybe there's just not an n-time algorithm for that. Also, first off, the memoization is all crap because we're only ever calling any of these once. You don't need this. All right, maybe it really is just the sieve of Arachnes. Let's go. Okay. PP equals true times n plus 1. PP says 0 equals false. PP says 1 equals false. 4. P equals sum. PP. Get rid of that. This was not an easy problem, guys. This has a lot of parts to it. I admit that I was a little stupid for that NK thing. I mean, like, I got it as soon as I simplified it. I was just, I don't know. I left in a minus C. It was confusing me. I shouldn't have done that. So we have to go from this to this. 4n in range. This can start with 0. N plus 1. I mean, I don't know. Like, how is this fast? Oh, I guess, well, we skip by I and we say PP sub. No, this isn't right. I times 2. PP, no, we don't want N here. We want J. PP sub J equals false. I think that's right. Do I still have an exit in there? I think I still have an exit in there. Yeah. Okay. So you guys see it's just a sieve of Arachnes. Maybe it runs in time? Did I get any more right? So if just the sieve itself is too slow, I don't really know what to do. We have to think about just how to do it faster. No, I don't think. The subfax thing seems fast. Think my sieve is fast? Let's see. Let's see if that's timing out. Okay, well, it's timing out on a few of them, but not that many. I mean, we're going to have to get them all right. So if we can't do this... Guys? Okay, I got an idea. I got an idea, bros. I got an idea. Who's ready for it? Who knows what it is? Who knows what the idea is? Who knows? Does anyone know? Imagination, what's your idea? Come on, you guys can figure this idea out. Oh, Lethy, you know? What's the idea? We're not smoking crack. We're not doing a tree, and we're not turning off the stream. We're not coding on Vim. We're not doing GCDs. I'm not allowed to smoke weed in my apartment. But that does sound nice. No Adderall. No. Oh, Uber Eats sounds delicious. No second latte. Oh, Lethy, you're very close. You're very close, Lethy. We're going to rewrite it in C. There we go. Change theme. We're changing the theme. Oh, this is going to be hard. Shit's unusable. All right, because it's not like I can't even make this any faster. It's not, my thing is now O of N, so that's not the problem. Ooh, C++ 14, that sounds pleasant. Oh no, we have to figure out how to read in int. All right, so let's go. Int nk, cnn, cnk. Is that right? Who knows C? Cout 10. Oh no, we're gonna have to figure out how to do that. We're gonna have to figure out how to do that in C, which I don't know how to do, but. I don't think there's a way to make this fast enough in Python. Okay, perfect. Bool p sub n + 1 for I equals to I less than. Can I just do square root of n + 1? Cast that to an integer. P sub I int I equals 2 for int j equals I times 2 j plus j less than n j plus plus p sub j equals true for if p sub I output is 0. Shouldn't be 0. Yeah, I know. All the languages have different time limits. I know they try to compensate, but like, I don't know. I don't think there really is a faster way to write that, right? And that's not finishing in time. I don't know why it's giving me 0. Okay, now it's giving me 1. And I'll also try the same algorithm. It's even harder to write this in this tiny little box. Six. That isn't right. Oh, I guess this should be. That'll make it right. 4. 4 is the right answer. Okay. All right, let's run that and see if we're getting out of time errors. I'm terrible at Minecraft, guys. I can't Minecraft at all. Oh, this is a new segmentation fault. Well, what am I supposed to do about that? Big stack? You don't like the size of my stack? Is that right? Compilation error. Is that the syntax? Is that not the syntax? Can it not tell me what my compilation error is? Define size of array. Oh, here we go. Array must be initialized with a bracket enclosed initializer. That's what I had originally. Initializer fails to determine size of PP. Okay. Shows you how much C++ I know. Okay, now we're getting wrong answer. And we have one timeout. But it's only one timeout, so this seems okay. This is an improvement. How big is that number? Fits in an int. Shouldn't have to deal with too much overflows. Okay. I guess we want to pre-cache all the facts and their modular inverses. There really isn't a faster way to do this, guys. If you think you have one, I'll be impressed. Stuff matters really for like the small numbers. 2 is going to add 1, so that's just fine. Don't need that. That's computed, right? Okay. Now we just have to figure out how to take inverses. Modular inverse C++. Not gonna work. Perfect. Thanks for the copy pasta. A mod m, okay. So now we can just do all the inverse facts. In fact sub I equals. Okay, this stuff there might all be ways to do faster. Just the prime thing. I don't really think there's a way to do faster. Mod inverse fact sub I comma n. Okay. Seems pretty good, right? See the problem? Honestly, I don't know if we have this much RAM. This stuff might not work. Yeah, AI winter's coming. Winter is coming. Hope everyone's got their coats. Hopefully they have 64-bit computers over here. N was not declared in this scope. Oh. What? I don't even know. In NCR. Okay, well, it's a number at least. What did we do wrong? Subfact minus Okay, well, it's almost the right number. CR should be mod in. numbers so big? I mean, this is why people don't code in these stupid languages. In fact, sub R, in fact, sub. I mean, these numbers actually seem a lot more reasonable than those ones. Oh, why is m minus k different? Where did k come from? Oh, I didn't subtract from n. Oh. Yeah. That might have been the whole issue. Well, the answer's not right, but I don't know what else I broke. Zero 6 0. Okay. Looks like the problem's only for I'm passing I equals 0 and the answer should be 1. We have some min thing for that. If I equals 0, return 1. Okay, all those numbers match. That last one doesn't. How did I add up a bunch of small numbers and get that? I guess because I'm multiplying it by subfact. I'm not multiplying it by subfact there. That gives me the wrong answer. I broke the Python. I broke the Python. Oh, it's because that's not the same as that. The Python is fixed. You make the same stupid mistake there. I haven't been talking too much. Hopefully you guys can follow along with this. It's not too bad. It's just porting. Just rewriting this in okay. Subfact doesn't match. Subfacts here are wrong. Subfact. No, it seems like it shouldn't be. Why is that 2? It's 4? Three is 4. It's not right. N mod 1. That's right. Subfact I minus 1, which 3 is not 4. Okay, so for 2, it's going to be equal to 2 times 0 plus 1, so that should be 1. And for 3, it's going to be equal to 3 times 1 minus 1, which should be 2. Oh. I make mistakes like that all the time. Okay, now it's giving me the right answer. Okay, well, a lot of wrong ones. This probably has to do with, yeah, so this is probably some kind of rounding issue somewhere. Let's just see where we forgot our mods. Oh yeah, we didn't even try. Why are there no mods here? Mod inverse is already mod, so we're good. Ooh, ooh. Oh, okay. We still have some that are too slow, but we got a few more. C++. Okay, so I'm pretty sure everything's O of N, right? I don't know what's not. I've washed my hands, bros. Okay. Get rid of that. Get rid of that. If the pre-caching's already too slow, let's just return here and see if these time out. The mod inverse might be too slow. Yeah, okay, we're getting timed out here. Maybe it's the mod inverse. Because if that stuff's too slow, I just don't really know what to do. The mod inverse, I think we can, if we're clever, we can do better. Okay, we're getting timed out on 2, but the mod inverse is pretty slow. Well, so let's think about this for a second. Here's an idea. I don't know if it's gonna work. Oh no, wait, n is bigger than. No, n is too big. Pragma OMP parallel 4. Yeah, I wonder if that'll work. We really need the m above is that if what we're doing with these is NCRs. But the NCRs, that's still probably the fastest way to do it. Like, maybe we don't need the NCRs. So also, like, we could mod inverse the numbers and not do it like this. Well, because what is a modular inverse? Yeah. Sam Altman, yeah, he's a trustworthy guy. They just took $1 billion from Azure. They call their organization OpenAI, and they post, basically news tier. GPT-2 is like news tier flame bait. Like, it's a moral, ethical, we're not going to release, and oh my God. And then what they did to that poor Connor kid, Connor Lethy, he reproduces it. Well, he didn't really reproduce it, but I learned that we have to set moral red. Yeah, you know how we do this with an actual open conversation. There were so many better ways they could have gone about that. So don't listen to Sam Altman. Real shit. Well, so see, DeepMind you have to respect. DeepMind never lied about what they were. And it's not to say that OpenAI didn't do good work. It's just, it's right. I think the people who should be punished harshly are the people who try to use open rhetoric and then are not open. People who don't use open, it's just, it's a general hatred of hypocrites. See, there's two types of people in the world. There's assholes and there's hypocrites. And assholes I can tolerate. Hypocrites not so much. I definitely think of myself as an asshole, not a hypocrite. I made lookup arrays. I'm gonna make this faster now. Like, I don't. No. This is already. It's O of n, unless the mod inverse thing's not. The mod inverse thing's sort of not. But no, also these people like they think, I don't know. There's going to be another AI winter. I think a lot of people are saying this. Deep learning solved a set of problems. They're very useful to certain industries, but that's been true for every other AI winter before this. Maybe we solved chess using massive search, and then Google starts using. It's just not even the same search techniques. I don't know. I don't know what I'm saying. Just trying to make this faster. How do we make it faster? Don't make it recursive. There should be nothing faster than this. I'm focused on this. Is there a faster way? No, I'd still have to invert all the numbers up to n if I wanted to. I could create the factorial in the modular space, right? Hard code 10 million factorials? I really don't think that's the right idea. Mod inverse is doing the Euclidean algorithm. Like, this is kind of slow. This stuff shouldn't be slow at all. I mean, okay, it's all the way to n minus k, but still, like, this is a bunch of multiplies. Right? Like, you can't even argue that that's, yeah. It's the O of 1 solution. This is the only thing here that isn't O of 1. Complexity of modular inverse. O of m. What's m? The mod? Oh! Who likes this? Yeah, this is the trick we want, right? Well, it's faster, probably. This is the same trick I used in Python. Wrong answer. Why is it the wrong answer? This is like the Montgomery algorithm. There's ways to make that even faster too. I don't, okay. Why is this wrong? Recursive, but n is definitely prime. That's right. I don't know. So like some things I can't invert or something? These should be 1 for all of them, right? Because n's prime. It's not. So there's a bug. It's not even 1 for all of them. What kind of power function is this? Oh, I guess that's... Maybe I need to change these to LLs. Yeah, that's probably not working. L does not name a type. Oh, I'm gonna make it name a type. I used to have like some copy paste shit that I would put at the front of all my competition programming that had like LL and stuff. I wasn't expecting this to become like a hardcore competition programming. Let's see how we're doing. I think we're gonna miss like a few of them still. We're gonna get more, maybe not. Okay, we're still slow. Time out. Let's see if it's timing out by here even. Log m. Wait, what? Okay, yeah, it's still timing out doing the inverse. All right, well, at least now we have simpler code. Now there's faster ways to do this. There's not that many ones in this, is there? That's a lot of ones. Great. No! Okay, maybe I don't need the inverses. Come on, this is like... This should pass. How do I get more time? This isn't really fair. This is like... Okay. In fact, R, in fact, n minus R. Is there any way like these are small or something? No. Is there any way to do it without the divide? Great. There was some other way. How is this one doing NCR? There's another way to do it. I mean, they divide, but they only divide by one thing. I mean, I guess you could rely on the fact there that K is pretty small. What, guys, my math is all right. I don't get it. I don't know. How do I make it faster? Maybe n minus 2 doesn't have a lot of... Does it have a lot of ones in it? There's a lot of ones in it. Modular power. This just might be faster. So this is like normal Montgomery. I've written this algorithm a bunch of times in like microcontrollers. What kind of a useless comment is that? Like, I hate people who write comments. Oh, initialize result. Well, no shit. Like, what do you think int res equals 1 does? Oh, we passed test case 29 now. We're moving up in the world. Slightly faster. There's not a faster algorithm for this stuff. I mean, we can make that an int. That doesn't need to be. We can make that an int too, but I don't think it matters. Assigned int. So somewhere to do this without choose? Has anyone ever solved this problem with HackerRank? This may not be solvable. So long to convert from long to int. I mean, Okay, we can make them all longs. Those can stay ins. I mean, this is now well beyond what anyone should be thinking about. Okay, is it failing all before? Is it failing all still in my pre-cache phase? Yeah, I mean, these are all failing here. Okay, maybe I don't actually need them all. This is unfair, though. Is it failing before the primes even? Only 34. I don't think so. I mean, it would be nice if I could pre-cache the values once. Oh. C is faster. Oh shit. No, 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 no. Please come back. Please come back. Oh, phew. Oh, if that deleted my code, I would have cried. I think C is, I don't know. I don't actually use C++14. Let's start with just C++. Maybe that's faster. Go. Nope, same ones. Who thinks C is faster? Well, okay. So I don't have to do these Alex. I can pre-declare them. It's 10 million. Yeah, we'll let the kernel do that crap. I don't know if this stuff's faster. Same bad ones. But actually, I don't think, I think if I just change this type def to a define LL unsigned long, no, I can't imagine, there's no way C is actually faster than C++. Yeah, I already used the modulus in this stuff. Everything's in the modulus frame. I mean, And it's failing, like if you need to invert all the factorials, if you even need all the factorials, I don't know. Maybe there's just some really clever closed form for this that I just don't, like, I don't know. His vision is very high. Okay. In other words, HackerRank is telling me they want me to think, not just spam anymore. Well, let's try this. Maybe we're wasting all our time on P. And we can figure out some faster algorithm for that. We probably can make that marginally faster. Huh, only 34. Okay. So the inv isn't that bad, it's just the combination. Of both. That's slow. Anyone have any ideas about faster ways to do the prime thing? Oh, no. If PP sub j, or sub I, equals 1, right? Because if it's already 0, that means it's already just a multiple of something, and then I don't have to do the inner loop. I think that's right. Yeah. Let's try that. No! You see why I think that's true? If we go back to C++ 14, it'll let me submit again, because it didn't make me do this until... No. Okay, so if PP sub I equals 1, if it's not already ruled out by the sieve, then we have to go rule it out, right? Because we only actually have to do this for numbers that are prime. Read chat for 1 minute. Okay, what do you want me to do? You calculate square root every second inner iteration. I don't think so. Do I? I don't think it's that stupid. The compiler will do that better. Imagination, what? Are you saying something? If PP equals big. Where? Oh, we got some more. Okay, we only have a few failing now. Yeah. I'm reading the wrong parts. What? No, okay, we made the prime faster, but the power thing is still slow, right? Like, they're both slow. Don't say I'm reading the wrong parts. If PP equals hard, great, you're funny. Dorkmo, thank you for gifting the sub. You are bro. Need all the in facts. Whereas if y and 1 I don't think C is going to be faster. Stop with the paste bin crap. Well, I can't believe 600 people are watching this. They're going to get it. Okay. So is the only problem left the in fact thing? Seems like they've started to throttle me because I'm using all their CPUs. I'm racking up their AWS bill. Okay, none of them time out anymore. So the only thing I think we have to make faster is in fact. Or we have to figure out how to not use in fact. A French guy solved it with Python. Well, you know, I'm American. We solve things with F-150s and Big Macs and yeah, American. Yeah, America. We love America. All right. Compute in the fact. This is what's slow. It's slow because there's an inner loop here. Well, the y doesn't change. We can pre-compute that for a y. Actually, we can pre-compute that exactly for the y. We don't need that, but that's not even in the loop, so it's not going to be faster. Yeah. We don't have the x's, so those we actually have to compute. That is almost the fastest way to write that. So we actually only have to compute it for the primes. And we could make all the other ones out of primes, but that seems like a lot of complexity. Y and 1. I'm not reading subtract subfact equals, yeah, no, that's not the problem. Subfacts are fast. Everything is being computed fast except for infacts. Well, you're telling me things that's not the problem. The problem, it's all this loop. If we could make this loop faster, we make everything faster. Huh. Well, I mean, now we can even talk about cache. No, it's not. No. The problem is all this loop. It's not the fact that those things are cache issues. That number squared won't fit in a... while loop to a for loop. I mean, I don't know. At this point, like, I don't know how this compiler works. We can unroll this whole thing. I mean, I guess there could be branch mispredicts here, and we don't really need that. We know exactly what... I'm upset that there's so many ones in this. See all the ones? They're very upsetting. B is a power of 2. Yeah, and that's exactly what this is. We multiply it by that, and that's all that. Okay. We don't need that. That's fast. There's a chance this is faster. That's not right. Wait, now more of them are failing. Okay, well, we've learned that C++ 14 is faster than C++. Okay, let's look up HackerRank CPU timeouts. Missions, leaderboard, discussions. Okay. Look how much time I get in Go. Don't make me rewrite it in Go. I will. The Go is just as fast as C. It's so unfair. Multi-threading is all, oh, CPU time would account for all thread execution time. Writing state information to a file. Can I really generate it all once? Unfair. Oh. Oh, you know what? I mean, it's not much, but a little more cache coherent. Yeah, see that tiny change, and now only 3 of them fail. PP1. If PP1 for int what? Fuck, I'm so close, I know. We're so close. Okay, so we actually don't probably have to do that. We can probably just say 0. Still, it's like n times stuff. It's not fair. Okay. I have one last idea. And there's no way I'm actually giving up, but we'll call it a last idea. We have to rewrite this in C. I will rewrite it in Go if that's what it takes, because I have 4 seconds in Go, which is really unfair. How you code C? I don't remember. Expected Put expression before int. Cool. Oh, different ones fail. Okay. Does this still give the correct answer? That'll help with cache. No, gives the wrong answer. I mean, technically, we don't need the RAM. We could cast them. We could cast them whenever we do a multiply. Store pre-compute in one array instead of 3. That's not faster. I'm focused on this loop. It's doing 32, but still that's the whole of 1. I'm calculating factorials insanely fast. Like, there's no faster way than that. It's cache coherent. Like, the only thing to really tweak here is this. It's nicer anyway, so we should probably leave it like that. The caching shouldn't really matter. I have enough RAM. Wants to rewrite it in Go. Okay, I mean, we can try inline the functions. Hate that it comes down to this, but maybe. Compilers should be smart enough to do this, though. Two left failing. 2 left. Oh. All right. That's not going to make it faster. I just think it looks nicer. Really fast sieve. It could be any of these functions. It should be all in registers. The only thing I'm thinking about here is a branch mispredict. Like, I could write that out. Multiply. Because it does have a fixed. All right, should we just do that? I think that's gonna bring an end to this. Python shell online. Okay. While n greater than 0. If n print res equals res times x. Run. Oh, did I mean to put parentheses around my shit? I guess I did. All right. We're just gonna hard code. No. Stop. That's not what I meant to do. Let's call it Y so it has the same name. Now let's go there with that. Y. Is that allowed in Python? I forgot. Print x equals x times x mod. Remember, we can also hard code this number. Okay. We definitely don't need that last x times x. All right, who's ready to bring this to an end? Oh, of course. With some semicolons. Does everyone see what I'm doing? Does everyone see how this will end things, hopefully? Come on, come on, come on. You're gonna work, you're gonna work. What? No, that can't be. No, come on. Oh, that's bullshit. Oh man, that's bullshit. I don't even... How? That's so unfair. Look at how O of 1 it looks. It's so O of 1. And that's definitely staying in the I cache. There's no more branches, is there? Oh, I guess this is a branch. I guess I could figure out how to fix that. I think I can actually just fix that. Fact 0 equals 1. Does that fix that? I think I have to deal with in fact 0 as well. That just might fix that. Let's see if it runs. Okay. We don't need that line anymore. Did that make it faster? I worked really hard on that. Can do it without primes. Try in C++ 14. Okay. I mean, the nice thing about C is it's valid C++. I don't know. Is this even being compiled with O3 or something? Is there a way to get Pragma O3? It's not gonna work. They tell me what language they use, right? GCC. Oh, those are different ones that failed. Pragma for faster GCC. They're different ones that fail. Like, it's so close. No, input's not the bottleneck. I don't know. This thing seemed to not help. If anything, that was faster. Guys, this never was supposed to take this long. This was supposed to be a little warm-up. I was going to sit and read today. But you know, I don't need 2 for loops on line 86. I don't have a line 86, so I don't know where you're looking. Here, I need 2 for loops here. $31, $32, $34. Okay, now more of them fail. We liked that. Okay. You know what? It's kind of bullshit, but let's do it. This will do half as many M facts. What's 2 factorial? It's 2. Is that right? Is that right? Wrong answer. Okay, I'm looking at you. I times I in Arachnes. Where? Is that stuff not, is this not correct? I times I instead of I times 2. Is that true? All right, I'll believe you guys. And I'll think about why it's true after we win. And then I can make in fact twice as fast pretty easily with some shit, so we'll try that next. Why is I times I correct? Don't pass Y as arg. Yeah, we don't really have to pass those as args either. That's a good point. Give up on any hope of that working. So close. So close. Okay, let's think more about this. Does this stuff not make sense? We'll do all the odd ones. Oh. Is that the problem? No, it's not the problem because it didn't even work for small ones. Too many arguments to function power. Well, yeah, of course. Undefined reference to power. Did I break it? Why? Is inline broken or something? It almost seems like a compiler bug. Okay, wrong answer. I mean, this certainly works, right? Yeah. So why is that not right? Put in fact back in the first loop. Okay. All right, chat, we're gonna try listening to you guys. Wrong answer. Oh, because it's so close. It's so close. OBS crashed. I don't know, guys. It wasn't even my internet. We're so close. Let's just try O2. Sometime O2 is faster. Wait, how did those ones fail? Because we O2, I don't know. Wait, did it die again? I don't know. Oh no, I think I'm just not playing. It's back. All right, let's put some music on. I could plan. YouTube chill beats. Okay, why is this wrong? Oh, because that's not how factorial works. Crap. Okay. Okay, guys. I have a plan. We're P, and we're gonna solve it. We're gonna just solve this. I know what it is. Okay. We're going to invert every number. We're going to create one more array. I'm going to call it inv num sub big. Okay. Now we're going to invert every number. Inv num sub I equals power sub I. Now, instead of I, we'll just do inv num sub I. Does that make sense? Okay, it's right. Okay, that itself might still be too slow, so we're going to use some cool speed up tricks. This is too intense. I can't do the music right now, guys. I can't do the music. We're going to solve this. We're so close. So close to great victory. Okay, 0 equals 0, 1 equals 1. I think there's actually also fast ways to get them all. I think there's actually fast ways to do this, but I don't know them off the top of my head. But I do know this is going to work. Let's just see. It might be fast enough. You see what I mean? Now we're computing in fact exactly like the other one. Is that a timeout or is that a wrong one? One left, boys. One left. No, don't worry. I know how to make this fast. I know how to make this fast. That'll make it twice as fast. Forgot a semicolon. Is this it? Is this it? Is this gonna be it? Let's go, let's go, let's go. Come on. Okay, wait a second. Wait a second. No. No, this is just random now. Fine. I'll write the generic version of this if I have to. No, it's only easy for powers of 2. I'm not dealing with that. Hang on. Can we think for a second about what multiplication is? There's like a way to just Karatsuba multiplication. I don't know what that is. Get rid of all the prime code. What? What do you mean get rid of all the prime code? Just try it again. It's gonna work this time. Come on. It's different ones. I've had all of them pass. No, forget Karatsuba, whatever. There's a way. That's fast. That is what it is. I don't know why. Why is I times I correct? Oh, I guess because we're looping up to the square root of 1, so that has to be I minus minus instead of I plus plus. Where? This might just be slower from a cache perspective. Because we're doing, these are random accesses now. Might actually be slower. We only use it there. Different ones fail. Compute all numeric inverses in field. All right. We're trying the pragma. I don't think I can unroll any loops. It's a completely different set that fails. That shouldn't matter. I don't know what can be a const expr. Do we have to rewrite it in Go? See, like, wait, let's think. We're actually just looping through all of these numbers one at a time. No, that doesn't help us. It doesn't help us at all. Pre-cache all inverses in our array. Okay, well, we can remove this loop. I think we can do this. You know, they get you your hopes up. Okay, C++ 14. It seems to not make any difference. I don't know what push options even really does. No, I don't think it matters. I think just like keep resubmitting and eventually it's gonna work. Should we switch to Go? I mean, this is almost Go, isn't it? What would I have to change? Wait, a set of disks is numbered. There are 25 prime numbers below 100, so get rid of the prime function. No, the I++ and ++I is not changing anything, unless for some reason they're not optimizing the code at all. I mean, okay, I have an idea. Cache coherency. Have you seen 30 and 36 fail before? I equals 3. Good point. You're right. It doesn't matter, but you're right. Go back to pseudocode and try rethink it from another angle. Yeah, okay, we'll add back in unroll loops. I don't think it matters. For I equals n, I minus minus. Okay, all right, fair point, fair point. Where? Okay. All right, you want this to be ternary? It should be the same. Yeah, I'm sure there's very clever ways to do all this, but we're so close. Like, I've seen every test pass, just not in the same run. Okay, you love my, all right, you all happy with ternary? Let's go. Come on, come on, come on, come on, this time. Yeah, boy. Oh. Ternary is worse. Ternary really doesn't do anything different, I don't think. No. There's a more generic way to do this, right? So we can do this. Like, we really only have to compute them for the primes, not even the odds, right? And that power function is slow. Subtract n from p in the while loop. Which while loop? Yeah, no, it's everybody else on the machines. These are shared machines. This is unfair. Well, I don't think you can, yeah, the only way to do that is really with that. It's slow, but there's not another way. I don't really see inline assembly helping. Compilation error. That's new. Oh, did I leave some crap? Yeah, I left some crap. Okay, let's try this. I did not mean to do that. Approximating the factorials. The factorials are so, this is O of n. Two of them fail. I mean, this might make things better. Now I'm willing to do it. Because this is using half the, use less RAM. Oh! Oh! Yeah, you gotta get that cash. Nice! Oh, we did it! Oh my god, it took all fucking day. Woo! Thank you for being here with me. You were all real bros. I hope you enjoyed. Look, we did, you know, I thought like, oh yeah, let's just find a little harder problem. Oh, it's gonna be medium. Oh, how hard could that be? Did I miss something obvious? Did I miss some bullshit? You guys all looked at the solution. Woo! Oh yeah, let's share it on Twitter. Yeah. I'm just gonna copy and paste it. No, we're not running it again. I don't want to talk about that. No. I think it actually got a lot faster because look at what we did. We changed these to ints. We changed these to ints instead of logs. So you just have the RAM, but it's not about the RAM usage, it's about the size of the cache, right? Oh, you guys gonna wash my hands for a while. It's over. Ooh, it's over. We did it. Oh, yeah. First you gotta scrub with like 30 seconds of soap. This hand washing stream. Oh, yeah, that's nice. That's nice. There's too much soap on my hands. We're gonna cook some eggs. Yeah, we'll whip up like a triple egg omelet, some scallion onions. We're gonna go read. My friend's coming to visit me tonight. Everything is good. Everything is good. I'm really glad you're all here with me. No Minecraft, no cooking. It wasn't this. When I'm on stream, I can't give up. I never want streams to end failures. Bitcoin, thank you for subscribing. Thank you. Oh, this is gonna get mad views. Oh, we got mad views on this channel. Worked real hard today. No, I don't know. All right, thank you. Thank you, imagination. The truth is, guys, I'll tell you one piece of advice for life, And I'm not going to tell you all where I learned it from. And it goes like this. Never give up, never surrender. No, it's from Galaxy Quest. It's a good movie. You guys should watch it. All right, see y'all later. Never give up, never surrender. All right, yeah, I gotta look. What? No, I didn't mean to move that one. No. Yeah, okay, right there. Yeah. Nope, moving the wrong one. Nope. Now I want to move that one. Yeah. Oh yeah. All right. See y'all later.